Okay, here we've got a question that pretends to be about the volume of water in the tank, but most of the time we're just going to be doing algebra with this expression for v in terms of t. dv by dt, just apply the rule for differentiations from chapter 5 to that. Out will drop the answer for 3 easy marks. They do generously mark the first time you have to differentiate something on the paper. And then 2 more easy marks for differentiating all over again to get d2v by dt squared. Then in part B we've got to find the rate of change of volume when t is 2. So we're going to be substituting t equals 2 into something. Rate of change is a code phrase. You met it in chapter 5. It just translates very easily into something you've been learning about, and as a clue it's something you've already worked out in this question. So look up chapter 5 if you don't know what rate of change means, and substitute t equals 2 into the relevant thing that you've already found. Then part C1, we've got to verify that v has a stationary value when t is 1. Stationary value is another key phrase. Chapter 6 will remind you of the definition of the stationary value. Clue, it relates to dv by dt having a particular value. And what you've got to do is substitute t equals 1 into the correct thing and get the correct answer out. It's verification, so we're allowed to start with the answer t equals 1 and check it does the job it's supposed to. So you substitute it into a certain thing, you get a certain value out, and you make a convincing comment. And then in part 2 of C, we've got to determine whether it's a maximum or minimum stationary point. Well, chapter 6 contains a rule that sometimes works in finding maxima and minima, and in core 1 it will always work. So you take your t equals 1, and you substitute that into the thing that chapter 6 tells you to, and you get an answer out, and again you convincingly interpret it, and you should get these last 2 marks.